Hi, everyone. Thank you for attending our session. Today, we are going to talk about equipment repair scheduling decision optimization for service providers. My name is Vijita Kaduvela. My colleague Zuen Chin, a data scientist, is joining me for today's presentation. We are from Kavi Global. Kavi Global is a data engineering and data science company based in Chicago. We specialized in software solutions and services. Today, let me start talking about the repair service providers. These providers can come from many different industries, whether they're in the manufacturing, transportation, healthcare, mining, construction, to name a few. These providers have physical repair shops or field services units. Physical repair shop is where the equipment will be brought in for repairs, and field services units on the other hand, goes to where the equipment is. Now, there are two different perspectives, whether you are an equipment owner or a repair provider. The main distinction is that for the equipment owners, repair is a cost. For the repair service providers, repair is a revenue. And while the repair services are provided, typically these equipment are out of service, therefore not generating revenue or value. And it is an objective for both the service provider and equipment owner to get them back in service as soon as possible. From the repair provider's perspective, unused repair capacity and labor at the shops are perishable resources, just like an airline seat or hotel room in that perspective. Many of these industries are also highly regulated, so regulatory compliance is a major activity that the repair providers have to abide by. So let me go through the problem statement. The goal is to minimize the movement cost, whether the unit repair unit goes to where the asset is or the equipment is transported to the repair shop. The movement costs need to be minimized. Total cycle time need to be minimized, and it is the best case scenario for the service provider to level load all their facilities. The current problem is mainly because of the legacy nature of these companies who provide the repair services. These are large companies, sometimes billions of dollars in revenue. However, their planning, scheduling, and status update and other work is typically done manually, a lot of spreadsheet, a lot of emails, a lot of phone calls. The networks themselves are very complex with multiple capabilities and legacy IT systems, and the resources have to jump across many systems to get some of the processes worked through. Demand is lumpy, typically usage driven or driven by the industry cycles. Typically low upstream visibility to demand, and manually these assignments are done. So therefore, the solution we came up with have three major components. One is the demand forecast, and then there are many different levels of demand I will talk about. And then the reservation system, so you can do advanced capacity planning and a scheduling optimization. That is the optimization algorithm to assign the right to repair to the right facility, and also minimize the other movement costs and the level loading facilities I spoke about. So one of the things before we actually go to solve these problems, one of the things we have to do is the benefit assessment or benefit identification. This is required typically for justifying any investment into advanced capabilities. So think of this as companies are trying to come from their legacy solution to more advanced digitally driven analytical solutions. So it's typically a part of their digital transformation. So the justification for these projects can come from two areas, or one showing them how this initiative can help increase the revenue. Other is how this initiative can help save costs, right? So the increased revenue, whether it's the level loading that creates capacity, increased resource utilization, a better mix, revenue management, and pricing, those two typically can be employed where the demand exceeds the available capacity. Then you can actually pick and choose or price accordingly. And better cycle time, if you can get the productivity of your processes up, that also contributes to the increased capacity and increased revenue. Cost savings typically come from the labor productivity, whether it's the increased labor productivity or the overtime reduction, and increased capacity utilization by providing more work during the low demand times, or inventory cost optimization also can help cost savings. So the demand has to be forecasted at detail level, at the plant level, at the facility location, and there are different demand segments, so types of demand. The unplanned demand, usage-driven demand, and a periodic demand. Periodic demand is typically governed by the regulatory requirements that certain types of maintenance has to be done at certain intervals. So if you look at these three kinds of repair demand across the predictability, variability, and urgency perspective, unplanned one is very difficult to forecast. But over time, with the large volumes of operations, it's somewhat predictable. Usage-driven demand is somewhat medium in the complexity, and the periodic demand is high in the predictability and low variability and low urgency. Therefore, it's easier to forecast. The other aspects of demand is the time horizon, short-term, medium-term versus long-term. The approach we have taken is a more hybrid forecasting approach. And demand planning, I mentioned a little bit about the reservation system that helps the customer service agents to manage the demand better, adjust their future workloads, and shift the demand where possible. So with that, I will pass the presentation to Xu En. She will talk about predictive maintenance. It's another aspect that, because of the availability of low-cost sensors, a lot of these equipment are equipped with the sensor which monitors the wear and tear, and you can plan basically the condition monitoring aspect of it. In the early days, you had to bring the equipment to a shop or have a crew go to where the equipment is and do a physical inspection to figure out the condition. Now with the sensors, it's possible to monitor the condition almost in real time. So with that, I will have Xu En talk about the condition-based monitoring and predictive maintenance and other aspects of our solution.
Thanks, Vijay. Before talking about the predictive maintenance, I want to start from the opposite concept, the preventive maintenance, which is often used by the industry owners, where they use some time or machine run-based scheduler the measure to make scheduling and the demand forecasting without considering the actual condition or performance of the machine or equipment. This approach often generates the usage-driven demand. But in order to increase the accuracy of the usage-driven demand and also add more predictability to the unplanned demand, we want to introduce predictive maintenance over here, which here we mainly use the data generated by IoT services, using the data such as the time, temperature, noises, and other physical data to generate and detect the causal structures, and then eliminate or control those stressors to any significant deterioration in the component physical state. The predictive maintenance is mainly achieved by some analytical approaches, starting from the statistical method of dimension reduction to eliminate the irrelated factors. We then use the real-time-based big data analysis, such as the rule-based AI systems and association and sequence analysis. This together can help us to detect the system failures. With accurate demand forecasting, we can then generate the reservation-based scheduling optimization. So starting from the scheduling strategy, we use the time horizon-based strategy. On the long term, we actually make some demand planning based on the expected demand forecast. So if the forecast is high, we will use mixed optimization and revenue management like Vijay had mentioned before, the select approach. But if the demand is low, we will then apply the CSR and sales team to stimulate more demand for the business. In the medium term, we will make reservations that have to be confirmed in the short term. Then coming to the short term, we will actually confirm the bookings based on the more detailed information like the location and work type. And then we make some preparation for those demands, such as the labor and material arrangement. The actual scheduling problem will be solved by this multiple objective optimization algorithm. So here our objective is to minimize the movement cost, the total cycle time, and the level load facilities. So here the total cycle time includes the transit time, waiting, and the repair time. And level loading actually is just to kind of spread the workload across different shops in the network. The constraints we are considering include shop capacity, capability, labor, and materials. And the inputs we are using includes the demand forecast and some shop level input. Then we can generate the scheduling, which is just to assign the right repairs to the right shop at the right time. So these are our solutions for the problem, which is demand forecasting, reservation, and scheduling optimization. With those foundations, we can also consider to manage the revenue using pricing and optimize the labor and material to better help the business generate more revenue and maximize the resources, the value from the resources. So these are our sessions. Thanks for attending the session, and now we are open for questions.